Hey folks, how you doing? We're on page 89, looking at number 5. We got 3 friends going to a football game. We got Rick, Brenda, and Ali. And there's 4 gates, and they didn't make a plan, so we don't know which one they're going to go. But we have probabilities for each one. So let's see if we can take this information and organize it a little bit so we can tell what's going on. So as far as Rick, if he's going to go to A, we know he's got a probability of 1/3. He knows there's an equal chance going to the others, B, C, and D. So 1 minus 1/3 is 2/3, and if we divide that by 3, or if we multiply it by 1/3, then we find out that there's 2/9 for each of the other possibilities. If you add those together, you should get 1. Now let's look at Brenda. Brenda's a little bit easier. She's got 4 entrances, and they're all the same probability, so that means it's 1/4, 1/4, 1/4, and 1/4. Ali, well, Ali's got C at 2/7, and D at 3/5. So if we add those together, and then subtract that from 1, we'll find out that we have 4/35 left over. And then we've got 2, so we divide it by 2 or multiply by 1/2. That's 4/70ths or 2/35 for A and B. So now we got the probabilities for all different gates. So let's answer the question. Probability that at least 2 friends choose entrance B. So the first one will be, let's say they all choose B. That's 2/9 times 1/4 times 2/35. But what if Rick and Brenda do and Ali does not? Well, now it's 2/9 times 1/4 times everything but 2/35. So that's going to be 33/35. Alright, so now what if we can do it so Rick does, Brenda doesn't, and Ali does? And we have probabilities for that now. And then, of course, there's the other possibility is that Rick doesn't go, but Brenda and Ali do. So then, opposite of 2/9, there's going to be 7/9. Brenda's still got 1/4. Ali now has got 2/35 again. And so then we've got our 4 different ways that this can happen. And all we've got to do is figure out what they are. You can multiply the numerators and the denominators are all going to be the same. So if you just multiply the numerators, and then add them up, you'll find out you get 96/1260, or 8/105, and then if we're writing as a decimal, it'll be 0.0762, 3 significant figures. Alright, now in part 2, they want to find the probability that all 3 friends choose the same entrance. Well, again, we've got different ways for that to happen. We've got 4 different entrances. So let's say first, if we talk about entrance A, well, if Rick, Brenda, and Ali all choose that, Rick's probability of doing that is 1/3, Brenda's is 1/4, and Ali's is going to be 2/35. Now for B, there's 2/9, 1/4, and then 2/35 for Ali. And see, all we're going to do is go through and figure out the probability for C now. And again, we have all the information on our table. And then all the probabilities for D, and these are the 4 different ways that they could go to the same gate. So we've got to find the probability of them all going to A by multiplying those, and we find the probability of them all going to B by multiplying those. We find the probability of them all going to C, multiplying those, and then D. And then we take each one of these probabilities and we add them together because we're willing to accept any one of those 4. And when we add them up, we get 2/35 or 0.0571 at 3 significant figures. All right, hope that helped. Thanks for watching.